Have you ever asked an AI a question and gotten an answer that sounds super confident, super detailed, but is also just completely, totally wrong? Yeah, that right there is what we call a hallucination. And honestly, it's one of the biggest roadblocks we have to really trusting AI. Today, we're going to dig into some really cool new research that's tackling this problem head-on with a completely fresh approach.
So, here's how we're going to break this all down. First, we'll get a handle on the hallucination problem itself. Then, we'll dive into a whole new way of thinking about how to train these models. We'll uncover two really clever signals that let researchers peek inside the AI's mind, see how they actually built a more thoughtful AI, and then we'll check out the results, which are pretty impressive. And finally, we'll zoom out and talk about what this means for all of us.
All right, first things first. Let's really nail down what we mean when we talk about this hallucination problem. Okay, just read this for a second. It sounds pretty legit, right? You've got NASA, a date, technical jargon, but it's completely made up. Mariner 2 was real, but it was an unmanned flyby, and it definitely didn't map Venus with radar. This is the perfect example of an AI hallucination. It sounds so fluent, so confident, but it's just not based in reality. And that's exactly what makes it so hard to trust these things.
But here's the really crucial part. The problem isn't just that the final answer is wrong. The research we're looking at today points out that the error usually starts way earlier. It happens because of these little breakdowns in the AI's step-by-step reasoning. Think of it like a student doing a long math problem. They make one tiny mistake in the second step, but keep going, and of course the final answer is completely off.
So, if the problem starts in the middle of the thinking, how in the world do you fix it? Well, the researchers behind this study propose something pretty radical, a total shift in how we teach these AIs.
And this slide, well, it just nails the big idea here. The old way is kind of like a teacher who only looks at the final answer on a test. You either get it right or you get it wrong. But this new way, the process-based approach, is like a teacher who's looking over your shoulder, watching your work. They're rewarding you for showing good logical steps and maybe pointing out, hey, you seem a little unsure here, long before you even circle that final answer.
Okay, so watching over an AI's shoulder sounds great. But how do you actually do that? It's not like it has a shoulder. Well, this is where it gets really clever. The researchers came up with two specific signals to get a real-time look at the AI's internal state.
The first signal is called an entropy spike, but the best way to think about it is like an anxiety meter for the AI. As it's generating a response, it's constantly making a choice about the very next word. Usually it has a pretty good idea, but if it suddenly gets really confused and has a ton of words to choose from, its anxiety, its entropy, spikes. And that spike is a massive red flag that its reasoning has gone off the rails.
The second signal is all about self-confidence, but you can just call it the honesty check. It's simple. After the AI gives its answer, it also has to say how confident it is. Then the system checks. Okay, you said you were 95% confident, but were you actually right? By doing this over and over, you're basically teaching the AI to be honest with itself, to really know what it knows and to raise its hand when it's just taking a wild guess.
All right, so we've got an anxiety meter and an honesty check. Now what? Well, now we see how they put it all together into a brand new training program, a new grading rubric, really, to guide the AI toward becoming a much better thinker.
See, the AI isn't just graded on the final answer anymore. That's the old way. Now, it's a whole new game. It gets punished for being overconfident and wrong. It gets rewarded for being confident and right. It gets penalized for those anxiety spikes during its thinking process. It's just a much more sophisticated way to teach, rewarding not just the outcome, but the quality of the journey to get there.
So, to put this to the test, they set up a really smart experiment. They took a pretty capable AI model and gave it a tough task, solving a bunch of challenging math problems. But, and this is the most important part, they forced the AI to show its work. It had to structure its output with these specific tags so the trainers could see its thought process, its final answer, and its own confidence level.
All right, that's the theory. That's the setup. But the big question is, did any of this actually work? Let's check out the report card.
And wow, the results are pretty darn clear. The new fine-tuned model didn't just get more accurate, though it did. It also got way more self-aware. Its calibration error, which is basically the gap between how confident it feels and how correct it is, dropped a ton. And look at that format validity. It actually learned to follow instructions.
Okay, let's zoom in on this calibration error, because this is huge. What you're looking at here is a chart of the AI getting more honest. A lower score is better, and that drop is a really big deal.
It means the newly trained AI has a much better sense of when it's on the right track and, more importantly, when it's probably wrong. That is absolutely critical if you ever want to trust an AI.
And here's the kicker. While it was learning to be more honest and self-aware, it also just plain got smarter. A 3 percentage point jump in accuracy on a tough math dataset like this is a very real, very significant improvement. It shows that a better, more stable thinking process leads directly to better answers.
Now, good scientists always double-check their work. The researchers ran what's called an ablation study, which is just a fancy way of saying they took the model apart to see which bits were doing the heavy lifting. And what they found was really cool. The honesty check alone provided a big boost, but when they added the anxiety meter back in, the model got even more accurate and even better calibrated. They really worked together as a team.
Okay, so let's zoom out. We've seen the tech, we've seen the results, but what does this all mean for us, for the future of AI?
Look, this was never just about getting better scores on a math test. This is about building trust, plain and simple. If we ever want to use AI in high-stakes fields like medicine or scientific discovery, we can't just have a black box that spits out answers. We need systems we can rely on. This idea of rewarding the process of thinking is a huge step toward creating AI that's safer, more reliable, and ultimately way more useful for everyone.
So this work is amazing. It proves we can teach an AI to be more thoughtful, to align its confidence with its actual ability. And that leaves us with one last, really big question to chew on. What's the next step on this journey? How do we go from an AI that's just correct to one that's truly self-aware? That's the challenge that lies ahead.